Starting the recording. So, first off, if you have any topics you want to go over, put them in chat, and then after I talk about the exam a little bit generically, I will go through as many of them as possible. So, your exam's on Wednesday. What's going to happen is I'm going to open it at 10:30. You don't have to start it early if you don't want to. But I think I talked a little bit about this the other day, but essentially what's going to happen is I'm going to write a 40-minute exam. Maybe, upwards of 45. And the way I do that is it's just you get 5 times the amount that it takes me. So I have to take the exam in not even 10 minutes. And so that's worked pretty well for me for figuring out how long the exam will be for the quote unquote average student. I don't know what that means, but for the most, that just means for the what it does mean is for the vast majority of you, if you're understanding the material at the level that you should be, you should take around 40 minutes. Of course, it's a 50-minute class, so there's already a 10-minute buffer in there for that reason, but I'm also going to set a 60-minute time limit. Now, this is an official time limit. Let me reshare my screen just in case. That's an official time limit. So the quizzes had unofficial time limits. So you could keep working after the time limit expired. This one you can't. Okay, so for this one, you'll have to take that 60 minutes. If you were going to take more than that 60 minutes, it will auto submit. So you won't be able to even have the option to continue. It will just be done after those 60 minutes. So be aware of that. If you were taking much longer than the 20 minutes on the quizzes, you should probably study that material a bit better so that you can do it faster, because those 20-minute time limits, that's the point of those unofficial 20-minute time limits on those quizzes, is that it should tell you about how long you should take on those. I haven't completely finished the exam yet, but it usually comes out to be approximately 15 questions. Some of them have parts, so one question might be an A, B, C or something like that. There's usually around 8-ish. I'm going off of last semester's. Last semester there was 8 multiple choice. I do these types of questions on my online exams. There are some examples in the review that I posted. They're find the error questions. So essentially I give you a problem completely worked out and you have to look through it and see if there's an error. So that's Sia, do we need to learn definitions or something verbal? I do not do like formal definition questions. I will not ask you, what is the definition of blah, 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 or something like that. The reason I don't do that is essentially if I ask you, I take it to be if I ask you for the average rate of change and you don't know what the average rate of change is, then you won't be able to answer that question. So I don't ask you official, like, what is the definition of something? But of course you'll want to know the definition so that you know the words in the question. The other ones are topics I'll get to later. Zoe in chat said, hey guys, if you didn't see the remind yesterday, my 2-hour test review is at 7. So test review for Zoe is at 7. Try to come on time if you can. I will be posting the review guide after class that we will use during this session. So if you have the chance to get to Zoe's review tonight, I assume that means tonight, it's at 7. Oh, I wasn't finished talking about the question types. So there's about 15 questions usually. Last semester, my first exam ran about 8 multiple choice, 2 find the error, and about 4 free response. So that exam was 14 questions. Now, again, find the error questions. I'm going to go back to that really quick. So there are some examples in the review that I posted. And so you have to look through it, tell me if there's an error somewhere. If there's not an error, you just tell me it's correct. Now, the thing with those is once you find an error, you want to consider the rest in terms of that error. And I think I'm going to scroll up to an example on the review. So if you really don't want to see the review, close your ears. But I want to go over this one because it's what I mean by this. So on this one, we were asked to find a formula for a linear equation between 2 points. And, you know, here's the thing that you're supposed to be looking through. If you start looking through it, the first thing you should notice is that the slope is found incorrectly. So they find the slope incorrectly, so you would note that as an error. But then for looking at the rest of it, you're going to assume, okay, if that is the correct slope, if 2 was the correct slope, do they do everything else correctly? Now here the answer is no, because there's one extra thing that was wrong, which is that second piece where they plugged the x and the y value into the wrong spot. So the slope being 2 there isn't part of the error because we've already pointed that out. But this is a completely separate error that didn't have to do with the slope being wrong. Like if they had put that in the, if what had been written down was this and they solved it correctly at that point, you would just say that the only error was the slope. You're not going to continue to point out this slope is wrong, this slope is wrong, so it made this wrong, that kind of deal. You're looking for like completely separated errors. So that's one thing with those. There's usually only 1 or 2 errors at most. And that's a thing. Do we need to correct the error? Good point. No. You just have to point it out and tell me why it's an error. You don't have to correct it. So note in this example here, I point out that the error for the slope is that they did the wrong calculation. Now, I will say, if you want to correct it, it will be usually accepted as a good enough explanation. Usually what I'm looking for is I want you to actually tell me what is actually wrong. Like saying, hey, the slope is wrong, it should have been whatever the number should be, isn't telling me that you know what they did wrong. So usually I'm looking for, this is an error because this. You don't have to fix it. If you can't think of another reason why it's wrong, you can fix it. If that's what you can, if that's all you can think of is, I don't really know how to explain why this is wrong, but this is what they should have done. But so see here, I pointed out the incorrect format that they used and then the correct format for the slope. And then for the second error, I said that they plugged them into the wrong spot. Like that's actually what is wrong, is that they took the x and the y value and put them in the wrong spot. And I note here, you wouldn't need to show it, but you could show the corrected version instead. I should not have said instead there. You could also show the corrected version as well. You do need the actual reason of why it's wrong to be fully correct. Hopefully that made sense. So that's how find the error questions go, is you have the work, you need to pick out the error, tell me why it's wrong. And if you found one of them, then you take the rest of it to be, you essentially take that to then be quote unquote correct. Like here, I just assumed, okay, let's assume that the slope of 2 is correct. Did they do everything else correctly? Again, usually there's only 1 or 2 errors at most. Sometimes there will be no error, so you need to be kind of careful on those. 60-minute official time limit. If you have extra time through the disabilities office, triple check that when you open the exam, it says time and a half would be 90 minutes. If you open your exam and the time limit does not say 90 minutes and you have extra time through the disabilities office, close immediately and let me know. Because I should have pushed through it. I have all of your names in a list and I should be going through and saying this person gets extra time, this person gets extra time. But if you open your exam, you're expecting extra time. Now, again, it has to be through the disabilities office. If you haven't gone through the disabilities office, you're not going to get extra time. But if you have extra time through them, it should appear on your exam. There was another thing and I literally just forgot. What was it? Oh, yeah. I'll be on Teams. I'll be right here at 10:30 because just in case someone needs it started early. You don't need to be. I don't see the point of having you all just come here and sit here in a black room and I'm gonna just be twiddling my thumbs. But I will be here for the entire 60 minutes. So I will be here between 10:30 and can only be here until 11:50 because then I have to jump over to my other class. Wait, no, 11:50? Yeah, that's what it'll be. I'll be here till 11:50. But then I have to jump over to my other class. So I'll be here on Teams for that long. Your test is on Blackboard. Just like your quizzes, same spot. It'll appear there on Blackboard under the assignment tab. Anything else? Oh, I do want to talk about all of that. So one last thing before we get into actual topics. So this is, of course, an online exam. So I want to go over what's okay to use and what's not okay to use. Now this is OpenNote because I don't feel like trying to deal with people using them even if I tell them you can't. So you can use your notes. Now, don't take that to mean that don't rely too heavily on your notes by any means. Still study as if this was a closed note exam, because if you need to go and look up every single question in your notes, you're gonna run out of time. You need to know the material so that you're only looking up a small thing here or there if you need to triple check yourself. You should be able to do these without notes, but your notes are okay to use. You can, of course, ask me questions. I'm going to say Aaron Hanna to be very specific. You can use already available, and I'll talk about that. See what I mean by that in a second. If this will scroll down, please. Already available online resources. What I mean by that is that what you can't do is you can't do things like Chegg, Reddit. I should write this as, hold on one second. You can't post to Chegg, Reddit, Stack Exchange, etc. to receive answers. Because that's considered having someone do the question for you, and that's just not okay. So you can't post the questions to Chegg, Reddit, blah, 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 blah. My exam questions are not already on Chegg. I check. So if my exam questions aren't on Chegg before the exam and are on Chegg after the exam, trust me, I'm gonna figure it out. Also, the answers you get from Chegg, if they answer quick enough for you to use it on an exam, are usually wrong. That's usually how I find how people have used Chegg, is because their answers are wrong. So just don't even. You can't talk to other people besides me. So you can't help each other out. I caught some people doing that on their final last semester. They got reported. It's pretty obvious if you're working together. So don't do it. Anything else you can't use? No, that's pretty much it, I believe. You can, of course, use a calculator. If you don't have one, I highly suggest Desmos, since, that's a website. You're allowed to use it. So one last thing about the available online resources. So it's essentially, it has to already be on the internet. So if you can look up a very similar question and you can use it to help you answer the question, that's perfectly fine. Again, if you're trying to do that for every single question, you will 100% run out of time. So that'll all be in the instructions on the exam as well. So blah, blah, blah. Any questions about the generic test questions? Okay. So first thing someone asked to review was demand equations, so demand and quantity equations. Sure. So let's see. That would be something like, let's see, a bakery. That's always my default. So a bakery finds that they sell, I don't know, 200 cupcakes. If they are priced at $5 and they sell, let's say 275, if they are priced for $3, assuming demand is linear, find demand as a function of price. I'm switching it up. Now, I'll hold on one second before I actually start so y'all can write that down. The big tip off here for how we're going to start this is that function of price language. So the vast majority of ones you've seen so far have been function of quantity, and I decided to switch it up because I can. And it's not necessarily always going to be the case that it is a function of quantity. So, oops. Demand as a function of price. See, this is actually going to partly answer your question. Potentially completely answer your question. So, one thing is that demand is in terms of price and quantity. Supply and demand equations are always in terms of price and quantity. So whatever, here we just have demand as a function of price. So the other thing is going to be quantity. So when we see the phrase function of price, that should make you think f of p, a function of price. Now that's going to give us the demand, but since demand is in terms of price and quantity, we're going to name our other variable q for quantity. If you named it d for demand, I would technically accept it, but just for moving to different questions later, it could be more confusing. So I would always put your demand and supply equations in terms of P and Q, price and quantity. So here, since we have function of price, F of P, so that phrasing is highly important to determining which one acts as the X value and which one acts as the Y value. Because if you think about it, our normal function notation is Y equals F of X. So if it's a function of X, a function of price, meaning that our price is going to act as our X value. And our Q's are going to act as our Y value. And the only reason I make that relationship is because I feel like a lot of people are usually better versed in Y and X instead of P and Q. If you can just do it in terms of P and Q and you can call it a day and you don't even have to consider Y and X, just do it. But if it helps you, because the first thing we would need to do here is we would need to find our slope. Now, before we find our slope, let me write our points. So remember, points are essentially always given as X comma Y. So here, since it's a function of price, we're going to have price comma quantity. So our 2 points that we have are $5 for the 200 cupcakes and the $3 for 275. Now I pulled these numbers off the top of my head, so I don't promise that they turn out to be nice. So if it was a function of quantity, it would be the other way. You need to be very careful and look at what the question is asking to be able to set it up correctly. So our slope would be, well, let me be, for review purposes, I'll be super duper, I'll write out all the things. So since we need a slope, we need a change in quote unquote Y over change in quote unquote X. So since here are the Q's are acting as the Y values, it will be change in Q over change in P. So we will have 275 minus 200 Of course, you can put it in the other way, as long as you're consistent. If the 275 comes first, the 3 has to come first. So we'll get 75 over -2, which I don't think comes out to something, well, it's not too terrible. -37.5 as our slope. Once we have our slope, you pick whichever, not equation, whichever point makes you happier and plug it into your, technically y equals mx plus b, but if we use our correct notation and our correct variables here, it will be q equals mp plus b. So we will have, I'm going to pick the 200 point because I like it better. You should get the exact same value if you use the other point. So you plug them into the y equals mx plus b, q equals mp plus b format. -37.5 times 5 will give you -187.5. I'm going to add the 187.5 over to the other side. So 387.5. So Q equals -37.5 P plus 387.5 would be your final answer. I've already said this, but I'm just going to write it down. We're not going to do it out fully, but I just want to write it down just to really hit the point home. If it were function of quantity, which is honestly the usual setup, but I wanted to switch it up to specifically point it out, we would have been using the points 200, 5 and 275, 3, which would make your slope, ugh. Your slope would have been -0.26 repeating, and I don't want to figure out what the b value would be. Finding out the slope was quick, but. So function of quantity would have been a very different beast there, because, whoops, should be an extra 0 in there. Anyway. So that's those types of questions. So you, again, that demand as a function of price is what tells you how to set it up. Function of is what tells you the f of p in this case. And whatever the f of whatever is the thing that's acting as the x value, and the other thing it's set equal to is acting as the y. What is our next thing? Questions, concerns on that question? Concavity using a graph. Sure. Let me try to leave like half of that in there. Concavity using a graph. Let's see. Let's try to do whoosh, whoosh. And let's do -2, -1, 1. This is probably not to scale because I'm just trying to break it up in the way that I need it to kind of be broken up in order to do the question. And I don't even care what this is. Okay, so concavity. So remember, concavity, we have two main options for concavity that's also split up into two different parts as well. So we have concave up and concave down. And remember, those can be, they don't need to be necessarily depending on the question, but they can be broken up into decreasing and increasing pieces. Here, let's just focus on concavity. So if I wanted to ask, where is this concave up and concave down? this little box in my way that you can't see. 1 second. So essentially we want to look at this and look for pieces that look like either of these two. Now the best hint I can give you for concavity questions is to look for the very obvious concave up and concave down pieces. So I have this piece right here that pretty much looks exactly like this concave down piece. And then I have this piece here. I don't know why I had to make it such a large box, but that is pretty obviously concave up. And then I have this piece back here, which is pretty obviously concave down. Everything else is a little wishy-washy, so point out the parts that are very obviously one or the other. Okay. Now there are no other parts of this that are obviously concave up or obviously concave down. Those are our only pieces. So that means that essentially we're only going to have 3 intervals. So depending on however many obvious pieces you have is going to be the number of intervals you're going to be working over. So we're only going to be listing 3 intervals here. Now between that first green box and the dotted blue box, somewhere in between those 2 boxes, it must have changed concavity, right? Because if the green box is obviously concave up and the blue dotted box is obviously, concave down, the green box is concave down, and the blue dotted box is obviously concave up, somewhere in the middle it must have changed. So we're going to go ahead and say we're going to take the nicest point in there and just say that's probably where it changed. For at this point in time, since we can't say exactly where it changed, we're going to take like the nicest point around where it could possibly change. And then if we go between the blue dotted box and the last green box, if it obviously is concave up and then turns to obviously concave down somewhere in the middle, let's find the nicest point here, it must have changed. Okay. So what this is going to mean, let me set up my answer here. Now essentially everything to the left of that first green box and everything to the right of the second green box is just going to match whatever was that concavity. So since this was concave down, it's going to be concave down for the rest of that part of the graph, which it is. It is concave down. It's increasing concave down there. So we would say from negative infinity to -1 is concave down. Now remember, you could also make that a bracket around the -1, not around the negative infinity, because it doesn't really matter. I'm going to just stick with parentheses. And remember, with these, you only care about the x value when you're listing our intervals. We're only caring about the x values. So then it's concave up from -1, and then we're saying that it's probably stopping and switching to concave down again around +3. So we're going to say it's concave up between -1 and +3. So then from +3 onward, it must be concave down again, which again, after that green box, it's still concave down. My drawing got a little wonky there, but that's what I was going for. And the way we can write that in interval notation, let me try to move this over a little bit to fit it on the screen. So we would put this little like U symbol, it means union, and go from 3 to infinity. Now, just to go a tiny step further really quickly, I'm going to breeze through this a little bit. If we wanted to look at increasing and decreasing, so we'd have a change here, a change here, and a change here. Let's say that's approximately 4.5. So essentially, if we looked at increasing and decreasing, we'd have these. So I'm not really explaining it, but but remember, you'll also want to be able to pull out increasing or decreasing, but that I feel is a bit easier to see because we just figure out where does it change direction. So from -infinity to -2, we're going upwards as we move from left to right, and then we hit a max and we started heading downwards. So from -2 to +1, we were heading downwards. Then we hit a min, and from there we turned back upwards from 1 to about 4.5 before we hit our next max and then went back down. Questions, concerns about that question? Okay. Scott, I'm going to jump to your question really quick because it relates to this one we had just done. And then I will get to Raylan's in 1 second. So how do you find revenue functions given the demand function or supply function? So here we found a demand function. Now, usually, again, we found them in terms of price, but it's actually, it doesn't matter which way you find quantity, demand or supply. So it doesn't matter which kind of format you're a given supply or demand for, you can still find the revenue function. Because remember, revenue, I'm not even going to put a function name. Revenue is price times quantity. So no matter which one your demand equation is in as a function of, you can always plug into one of those two values. So notice when we have our demand function, we have the Q in this case. Sometimes you'll have the P, sometimes you'll have the Q. But in this case, we have Q. So what you do is you just leave the P alone, and then you replace the Q, whoops, with the demand equation. So to find revenue given demand or supply, this can work for supply as well, you're going to replace either P or Q, depending on what your other equation is solved for, and you're going to replace that into the kind of generic revenue function, and then you usually also then distribute that variable to write your final answer. So you replace with the equation based off of whatever one it's solved for. Go through that. Cool. Exponential equation. Yeah. So I'm glad you asked that, Raylan, because I actually wanted to go over that too. So exponential equations. First thing I want to do is how do you figure out something is exponential and how do you find the equation if it is? So let me do 1, 2, 4, 6. Let me just do 4 terms. So we're not here for 5 million years. Let's do 5. And nope, let's do oof. And then oops. Okay. So say I wasn't sure whether this was exponential or linear. Remember, when we're looking for a linear relationship, we want to look at slopes. So that's when we kind of took into consideration how the x's changed and how the y's changed. So the x's are changing by 1 and then by 2 and then by 2. And hold on, let me hold on a couple seconds so y'all can write that down. And then if we look at what our y's are doing, you might be able to guess that it's not going to do anything of note. And remember with the linear, I'll say linear check. you technically need to look at the change in y over change in x's. So we'd be comparing like 1.17 divided by 1 versus the 3.2254 divided by 2 versus the 4.9115 over 2. These are all, they don't come out to do the same thing. The real big piece is the fact that both of these are divided by 2, but they don't have the same numerator. So that's a big tip off that you don't even really need to put it in your calculator. So that's definitely not linear. But is it exponential? So remember, for exponential, we're looking for a constant factor. So the factor is when we want to look at the ratio of the y values. But we also need to take into consideration how the x's have changed. So notice between 1 and 2 that it just increased by 1. So since those x values just increased by 1, we can just divide the y values. I'll move this down real quick. The y value of the larger x must be the numerator. This might mean, not in this case, I probably should have done that. Sometimes that means you're putting the smaller y value on top. It's always the y value of the larger x value that must be in the numerator. So if we do that ratio, we get 1.2234. Now, if we look at the next set of data between 2 and 4, let me set up the ratio, but not calculate it yet. So I set up the ratio, but notice that, come back. Notice that the x values changed by 2 instead of by 1. So what that means is I had to take a root of this. Now in this case, it's going to be a square root because it increased by 2. If it increased by 3, it would be a cube root. If it increased by 5, it would be a fifth root, and so on and so forth. So if we take the square root of this ratio, 9.3954 divided by 6.17, you get 1.233999703, or approximately 1.234. And then we'll have to do essentially the same thing in the last piece, because if we set up the ratio, but the x values increased by 2, so we have to take a square root. 14.3069 divided by 9.3954, you get 1.233999926, otherwise known approximately as 1.234. So I noted when we were first looking over this that we want to make sure that they agree up to at least 3. It's better to try to make it 4 decimal places. But if we round all of those to 4 decimal places, the first one comes out to exactly 1.234. But if we round the other 2 to the 4th decimal place, then they match exactly. Okay. So yes, they're not actually the same exact number, but that's a rounding issue. Like I rounded those two, the 9.3954 and the 14.3069. I rounded those when I was calculating this. So that's why sometimes they don't come out to be the exact same answer, but if they are the same up to 3 or 4 decimal places, you're going to call it good enough. So that would mean that this data is exponential. Yay! Now, what if I went a little further and asked you to actually find the equation? Questions, concerns up to that point? So if I want to actually find the equation, I'm looking for some p naught a to the t. That a value, remember that's the factor. I always said if you see the word factor, it's the a value. So since we were searching for a factor, your a value is going to be that number that you're finding when you're taking these ratios. Now P naught, if I have x equals 0, then I know what P naught is, but I don't have x equals 0 here, so I will have to find it. So to find P naught, you can pick whichever one of those points makes you happiest. I'm going to pick 1, 5. You're going to plug it in, including the A value that you have from the ratios. Sorry. And maybe I should have put an X here to make it super clear that, remember, within exponential, the variable that acts as the X is always the exponent. A lot of times it's a T value, but here I wrote an X, so I should have been careful about that. And then you can solve for P naught. So we would essentially divide 5 by 1.234 because we don't have to really do anything with this power of 1. So we would get P naught is approximately 4.052. And rounded to the third decimal place. So then your equation, 4.052, 1.234 to the x, let's say, because this was given us an x value. So linear has a constant slope, constant change in y over change in x. Exponential has a constant factor, which is the ratio of the y values, sometimes with a root on it. So if your x values are not consecutive, your x values increase by more than 1, you need to take a root. If it's an increase of 2, it's a square root. If it's an increase in 7, it's the 7th root. Also remember, for calculator purposes, if you're trying to calculate something like whatever, you can type it in as a fractional exponent. So like 2 over 7 to the, if you have a really old calculator, you'll have to put it in parentheses. But the newer calculators are nice because it just takes it up to an exponent. But you can use, there is a way to get the root on a calculator. You have to hit the math button and then hit like 4 or 5, depending on whether or not you want a cube root or a something other root. If you want a something other root, you would have to put the number in first. So say you wanted the 7th root, you'd have to type in the number 7 and then hit the math button. Actually on a newer calculator, okay, on a newer calculator it doesn't matter, but on an older calculator you would have to put the number in first. Anyway, is there any way we can see answers to our weekly quizzes to review? I have tried my very hardest to allow that to be a thing. And I think you should be able to, except maybe this last one. You should be able to see this last one after today because I have some people who needed to make it up. But you should, from the thing that the options that I have on Blackboard, you should be able to. I think you'd have to like go into your gradebook and then click on the actual score, I believe. There's no way for me to see what you guys see, which is a thing I hate about Blackboard because I still haven't, I'm not used to doing things online still. So check that out and see if you can see maybe quiz 2 or 3. If you can't, send me an email because okay, so yeah, the very latest one, quiz 4, I will definitely correct the option so that you can view it today. So the 4th one, quiz 4, you can't see yet because Blackboard is the bane of my existence. But after today, after everyone has made up that quiz and it's all good to go, I will fix that so that by the end of the day, you will be able to see quiz 4 answers as well. I wish there don't get me started. I hate it. Anyway, cavity, exponential. How do we know if it's X and Y? Revenue. Any more questions? I think I've hit every question that was asked, or if I think I hit your question, but I didn't. Exponential decay. Sure, like a question that has decay in it. Let's say, let's see. Actually, I don't remember what number this is. 4. Not that it matters. But, so exponential decay. Let's say something like a town starts at a population of 500,000. And let's do one like this. And 5 years later, the population is, ooh, this is not going to come out to be a nice number, but it'll be all right. 375,000. Find the percent decay rate. So it's quote unquote clearly, I don't like using those types of words, but it's hopefully somewhat clear that this is decay because it decreased. It started with a 500,000 and resulted in 375,000. So if I want the percent decay rate, essentially what I want is I want the R value. It's actually going to take a pretty decent amount of work to find. So what we have at this point is we essentially have 2 points. Let me say one last thing. Let t equals 0 be the first year. This is poorly worded. Essentially, we're going to let the 5,000 be times 0. 500,000 be times 0. I don't like how I worded that, but we're running out of time, so I'm not going to think of a way to phrase it better. So we essentially have 2 points. The 0, 500,000. I should just pick smaller numbers. And then 5 years later, 375,000. So what we can do with those 2 points is we can set them up in the equation p equals p naught a to the t, find the a value, and then get the r value from that. Now there's another way you could do this, but just to remind ourselves of how this type of process can go. So because we have the initial value, we could take a shortcut, but I'm not going to. So I'm going to go the full way. So that way would be writing p naught a to the t, and then the other one. And remember, the process I'm doing is essentially finding the equation. And remember, when we do that, I suggested putting the one with the larger t value on top, because the next thing you do is you divide, I'm missing a 0, is you divide the 2 equations. So that's why I wrote the other one first. I kind of flip-flopped them. Sorry about that. So we can divide these 2 equations. Oh, that came out way nicer than I was expecting. Wow. P naughts cancel out. And remember, it's you subtract their exponents. In this case, it's not very interesting because 5 minus 0 is just 5. But if that were anything besides 0, remember you subtract their exponents. We'll have to take the 5th root of both sides, or to the 1/5 power if you prefer. We'll get a is approximately, let's take 4 decimal places, 0.9443 decimal places. Let's take. Now, questions concerned about how I got that. So for some reason, we just wanted the equation. We'd essentially be done because we have p naught, we have a, we could write p naught a to the t. But that's not what we were asked here. We were asked for the percent decay rate. So we want the r value. So remember, a is 1 plus r. So if I want r, I can subtract 1 from both sides, get a minus 1 equals r. So if I take this a value that I found and subtract 1 from it, and we'll get negative 0.056. which as a percent would be negative 5.6%. So usually instead of listing the percent as negative, you'll say something like 5.6% decay rate. And you'll drop the negative because the word decay essentially tells you that it's negative. One last tiny thing I'll say about this, say this was a different question where you were given the decay rate. If you're given the decay rate, you need to remember to make it negative when you calculate the R value. So we're out of time, so I can't do one of those because I've got another class I got to jump over to. But if you're given a decay rate in the question and asked to like find the equation from it, make sure to take that decay rate and make it a negative decimal. If you need to leave, feel free to pop out. I can stick around for a couple more questions if you have any. Otherwise, I'll see you on Wednesday. Well, I might not see you on Wednesday, but your exam's on Wednesday. Don't forget, Zoe has her SI tonight. Study well. Let me know if you have questions. May the odds be ever in your favor. Have a good day.